Hello students, I am Suji George, an online chemistry tutor from Kochi. I am a postgraduate in chemistry and also I have a BA degree. Today the topic that I'm going to take is, as you can see, it's from the chapter Atoms and Molecules, class 9 and syllabus is CBSE. So you all know what happens if we divide. We take a piece of apple and we are cutting it into smaller pieces, again cutting it, again keep on cutting it into very, very small piece. And we will reach a position where it cannot be further divided. Okay, right? With the help of the knife. We reach a point where we cannot divide it into further. Okay. So similarly, scientists and philosophers also from way back in the history of India, there was a rishi called Maharishi Kannad in the 16th century. He was the first Indian philosopher who proposed the idea of an indivisible particle. That is, he named it Parmanu, an indivisible particle. The substances or padarth, what we call in Hindi, when it is broken down into pieces, again into pieces are made into small pieces, we reach a position where we cannot divide the particle again. And he called it in the name called Paramanu, which means the smallest particle of matter that cannot be divided. Okay. And again, his contemporary Pakuta Katyana also said that matter is made up of minute particles that combine in different ways to form substances. And not only them, but Greek philosophers also. Why are they were called philosophers during that time? Because these were all theories. These were all in the minds of these people, great people who used to think a lot and read a lot. They are all philosophers, Jnani. Oh, they are the ones who they'll be telling about something, and it is our duty or the scientist's duty to find out or prove whether it is true or not. So similarly, Greek philosopher around the same time, Democritus and his teacher Leucippus in Greece proposed a similar idea. Okay, so let's see what did they say. He also said the same thing, and that a substance is made up of smaller particles and that indivisible, something that cannot be divided further. Tiny particles are made up of, or substances are made up of tiny particles, and they named it atomos, meaning indivisible. And they also believed that all the matter is composed of tiny, indestructible units. Okay, these were all philosophies and they weren't proved whether it is right or wrong. So, this was around 6th century, and years later, a scientist called, what is his name? Can you read this out? Antonio Lavoisier. So that is Antonio Lavoisier, and he is the father of chemistry. And he proposed, so these ideas were there in the minds of the philosophers, and knowledgeable people during that time were doing experiments and studying a lot more about all these things. Okay, they kept on studying about things, and finally Antonio Lavoisier came into some conclusion. So let's learn about Antonio Lavoisier first. He was born in France in 1743. And look at his figure. He has got a wig. Even Isaac Newton also has got a wig. It was the attire of noble people during those times. All dukes and high society men used to wear all these things. And somewhat they look funny, in fact. But they are all people with brains. Okay. He gave the name. What are his achievements during those days? He gave the name oxygen. He was the first one to write chemistry with balance and accuracy. So, what was his discovery? Lavoisier said mass is neither created nor destroyed in a chemical reaction. And he also proved that air has oxygen in it, which helps things to burn. He also showed that water is made up of hydrogen and oxygen. So these were the things that he found out, and further there were other things that he has found. Okay, let's move into our next slide and see what has he discovered or what is his amazing laws of chemistry. Okay, so these are the laws that Antonio Lavoisier and his contemporaries, or there was a group of scientists who were doing experiments. You can see at the background, he's in a lab and doing some experiments. So what did he found out? He found that mass can be neither created nor destroyed in a chemical reaction. For that, there is so many chemical reaction where here an example is given. 2 grams of hydrogen gas and 16 grams of oxygen gas were made to react to form 18 grams. If you measure the weight of the reactants and the products formed, it was found that both were equal. 2 plus 16 is 18, right? So from these experiments, again they did so many other experiments which has been explained in our textbook. And this says the law, or it proves the law of conservation of mass. And there was a second law. It is called the law of constant proposition. And both of these are called as laws of chemical combination. And the second law states that in a chemical substance, elements all are always present in definite proportion by mass. Okay. For example, if you are taking water from the tap, water from the lakes, water from the river, or dirty water, or water from the ocean and or well. If you take water from these and also rainwater, you are collecting it, and if you study about it, it is not different. The chemical substances present in it is hydrogen and oxygen, and they are in definite proportion. That is, 2 hydrogen reacts with oxygen and only we will get water. Okay, and there is a proportion with which it combines. Okay, so these were the things that Lavoisier, along with the scientists, noticed that many compounds were composed of 2 or more elements. Okay, right. And each such elements had the same elements in the same proportion, irrespective of where the compounds came from or who prepared it. Okay. So this led to the law of constant proportion, which is also called as what? Law of definite proportion. And this law was stated by Proust, another scientist. Okay. So no matter if you take it from a river, tap or rain, the formula of water remains the same. Okay now. And those were found out during the time of Antonio Lavoisier. That is, law of chemical combinations were there, and that states that matter can be neither created nor destroyed, or substance cannot be destroyed. And again, it was said that the elements combine in constant proportion. So these were found out, but the problem faced by the scientists was to give an appropriate explanation. There weren't appropriate explanation or experiments to prove that that was correct. So a British scientist, he is a mathematician, he is a school teacher, he used to teach mathematics, physics and chemistry, and that is John Dalton. Okay? And he explained, or he provided a basic theory about the nature of matter. Okay? Dalton picked up the idea of divisibility of matter, which was still then just a philosophy. He took the name atoms were given. The name atom was given by John Dalton, and said that the smallest particles of matter are called atoms, and his law was based on the laws of so he had given certain laws regarding the atom that was called Dalton's atomic theory, and this law was based on the laws of chemical combination. Okay, so according to that, let's see what are the postulates or what are the main objectives or rules of this theory. What does this theory say? There are six postulates, and that postulates is an important topic that you need to learn it. And it states that, what was the first one? All matter is made up of very tiny particles called atoms which partake in chemical reactions. The atoms are the ones which partake in chemical reactions. Okay, and it is made up of, sun matter is made up of tiny particles called atoms. Okay, and next one is, atoms are indivisible particles. We cannot further divide atoms. That was what John Dalton said. And is that true or not? We will find out later in the class. Okay, so atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Again, the third one says atoms of a given element are identical in mass. So, earlier Lavoisier was talking about some elements which combine together. So, elements are made of atoms and they are identical for a particular element. The atoms are identical in mass and chemical properties. Again, he said atoms of different elements are different mass and chemical properties. So atoms combine in the ratio of, this is what Anthony Lavoisier and Proust said, right? Atoms combine in the ratio of small whole numbers to form compounds, definite numbers, right? And next one is the relative number and kinds of atom are constant in a given compound. So these were the postulates of Dalton. But later on, there were setbacks. Okay, later on, scientists proved that atoms can be divided. And can you tell me? Yes, of course, atoms can be divided into smaller particles, or atoms contain even smaller subatomic particles, and the main ones are protons, neutrons and electrons. So first postulate itself, the second postulate itself was proved to be wrong. And again, scientists found out about isotopes and isobars, and the third and the fourth postulates also was proved wrong. Okay, so there were setbacks for his postulates, but during his time, no, there weren't sufficient place for doing experiments or techniques for that, but during that time he managed to derive or come into a conclusion about these theories. Okay, so let's see what are the drawbacks. We will be studying about this in later in this chapter. So atoms are not indivisible. Yes, atoms can be divided into subatomic particles. Second one, all atoms of an element are not the same. Okay, he said it is same, but it is not true. Some elements have isotopes. Isotopes are atoms with same number of protons but different number of masses. There are isobars, atoms of different elements but have same mass number. This we are going to study later in this chapter. Okay, so one thing is that atoms of same elements can have different masses and atoms of different elements can have same masses. That was the thing. It was said in the other way. It was proved wrong. Okay. Atoms can be created in nuclear reactions. Okay. So atoms can be divided and split. In sun, what happens is nuclear fission and nuclear fusion happens in sun. That is how sun produces this much amount of heat due to nuclear reactions happening. So in a nuclear reaction, an atom, a whole atom can be split into other two atoms of different elements. Okay. So that also been proved wrong, and he also couldn't explain different compounds with the same elements. For example, carbon dioxide is made up of carbon and oxygen. And according to the earlier theory, it only reacts within a definite proportion and all, it was said. But that was proved wrong later on, because carbon could react with one oxygen, and carbon also could react with two oxygen as well to produce different compounds. Okay, so that was the atomic theory of Dalton, and that is important portion from this chapter. And then the drawbacks. Okay, so later on it was proved that by doing further experiments and all, it was proved that what? Atom is divisible. So let's see what is inside an atom. Okay, so there is an atom. We know that there is subatomic particles like protons, neutrons, and that is present inside the nucleus. So if you take the whole atom, in middle of it, sometimes in the middle of apple you can see seeds. Similarly, in the position of seeds, if you think about an apple as an atom, then the part where seeds are kept is the nucleus. Okay, and inside the nucleus there is, hope you can see it. Yes, now you can see, inside it you can see this portion. It has been enlarged and shown here. And so inside the nucleus there is protons and neutrons kept, and you can see that electrons are revolving in high speed. Because since it is revolving in a high speed, if you take a picture of it, we feel, or the picture shows that there is an electron cloud around the nucleus. So center of the atom, at the center of the atom lies the nucleus containing protons and neutrons, which amount for nearly all the mass of atoms. Then the electron cloud surrounding the nucleus is an electron cloud with electrons occupying discrete energy levels and orbiting the nucleus in a special manner. And these are orbitals where electrons are arranged. You don't need to learn about orbitals in the small class, but till here you need to learn atoms are made up of protons, neutrons and electrons, and the very thing you need if you Can you see atom with our naked eyes? No, it is very, very small. Very, very small means its radius is measured in nanometers. Nanometer is equal to 10 raised to minus 9. And 1 meter is equal to 10 raised to 1 by 10 raised to minus 9. That means, what does 10 raised to minus 9 means? 1 by 10 raised to 9 mean? It means after the decimal point there is 9 zeros and then only the number comes. That small tiny is a atom. So the radius of an atom is measured in nanometers. Okay, now let's study about the names. We have Antonio Lavoisier who said about elements, and all the objects that we found in the nature are made of elements. And again, Dalton said that elements are made up of same kind of atoms, and if different kind of atoms combine together, we get compounds. And so, do you know how many elements are present in on Earth's surface? Yes. How many? 190. Yes. And in 190, these elements are arranged in the increasing order of their atomic number. And what is this atomic number? It is the number of electrons or protons present in the molecule. So first one is hydrogen because it contains only one proton and one electron. So it was given the name, it was given the number 1. Hydrogen 1. Okay. So before that, let's see, take a look into your textbook. What is an atom? It is said elements are made up of small particles called atoms, which shows the same property, same physical and chemical properties of an element. And each atom is like a building block. Okay, it keep one over the other or added together, we get an element or we get a big piece of metal, you can say. And it is only 1 by 10 raised to 9 meters, or 1 nanometer is equal to 1 by 10 raised to 9 meters. That means 0. We have need 1, 2, 3, 4, 5, 6, 7, 8, 9 and a 1. Okay. So that is how small an atom is. Okay. And I told you that these elements are arranged in a table called periodic table according to the atomic number and also its repeating chemical properties. Okay. So if you look at the periodic table, you can see the columns of elements have the same properties. Okay. Now, so what are the modern day symbols? So earlier, can you name some elements for me? Okay, you might have learned that in your biology classes, minerals required for our body to maintain our good health. What are they? Yeah. One, magnesium. We need sodium for our thyroid to function, magnesium for our heart to function. Iron is necessary. Then what else? Zinc is needed. Then potassium is needed for the smooth functioning of body. Calcium is needed. Okay, so these are elements present in the periodic table as well. Okay, we will call it as minerals. So these are all metals, and see their name. If you are going to write their names one by one, or if you are going to write about a chemical reaction that is happening, for example, chemical reaction of copper sulfate reacting with sodium carbonate. And if you imagine that we are a scientist or somebody working in the lab doing experiments, and writing down these names, lengthy names, is a big problem. So for that, for easy writing, what happened is our Dalton has found out an easy method. Instead of writing hydrogen, he chose to write like this. Okay, and instead of writing oxygen, he chose to write, how did he write? Okay, that oxygen is fine, only one big circle. And what about sulfur? You can see here sulfur was written like a cross inside the circle, and then iron was written I inside a circle. And what about mercury? Instead of writing it, it will become very difficult putting the circle and then putting all the zeros and all the small dots. And gold also looks very uh, tedious for writing it down. So these were the first symbols of some elements proposed by Dalton. But later on, a scientist or a teacher called Berzelius suggested that symbols can be made from one or two letters of the name of the elements. Okay, so if it is magnesium, we can write hydrogen can be written as H, taking one letter from the name, and magnesium can be written as Mg, taking two letters from its name. Okay, what about zinc? Again, is it N? Calcium Ca. Okay, that is one method. Okay, let's see other methods that were used, or what are the rules, or how these elements were given their names and what were taken for that. Okay, so in the beginning, the elements were derived from the name of places. Okay, can be written according to where it has been found. For example, copper was being found from Cyprus, so it was written as Cu, or copper's name was Cupra. And some names were taken from their colors. Gold is taken from its color, in an English word meaning yellow. But that was the way they did it earlier in the history. But nowadays, what were used? IUPAC. What is the full form of IUPAC? International Union of Pure and Applied Chemistry. So it is an international scientific organization which approves names of elements, symbols, and units as well. Okay. What are units? Meter, kilogram, all those things. Okay. A meter, ampere, joules are all units. And IUPAC was the organization which approves. If somebody has come forward with a name, this organization has to approve. Okay. So, what were the rules that they suggested? Let's see. Okay. Many of the symbols are the first one or two letters from the element's name in English. Okay. For example, I showed you magnesium, and the first letter of symbol is always written as a capital letter, uppercase, and the second letter as the small letter. Okay. So let's see, an example is given over here. Hydrogen. So hydrogen, we write it as H, capital H. What about aluminium? Al was used. A, or the second letter should be small l. Okay. And then what about cobalt? C and small o. Okay. So these were the first rules. Two letters from the name. Or they could also take some elements are formed from the symbols of some elements are first letter of the name and any other letter appearing in the name. For example, what is the example given over here? Chlorine. So they took C and L, any other letter that comes after in the name. Or zinc, we can say it is written as Z and N, small n. Okay, and some other, I haven't, if you have noticed, I didn't write the names of these sodium, iron and potassium over here, right? These were given, the name or the symbols were given from its Greek or Latin name. So in Greek, sodium was called as, or Latin name was natrium, and from that derived, or Na was taken as the symbol. And then what about iron? Iron's name was ferrum, and from that Fv was taken as its symbol. And then comes potassium. Potassium was called as kalium, and so K was taken as its symbol. So these were the things that, or these were how we used to name the symbols. Okay. Other symbols have been taken from the elements Latin or German or Greek. For example, ferrum. Latin name ferrum is for iron. Sodium is Na from natrium. And potassium is K from kalium. Therefore, each element has a name and unique chemical symbol. And by the passage of time and repeated usage, we can also learn how to write these names of the elements in symbols. Okay, so I want you to learn about the names, some important names of elements, especially from 1 to 20. It will be very useful for you. So let's learn that. So first, this is a small, short, sweet periodic table. It is in the periodic table. It's a part of it. It contains 1 to 20 is the number of what? Elements present. Okay. So first one is hydrogen. Second here it's helium. How did helium or hydrogen get the numbers 1 and 2? Because hydrogen contains 1 proton or it contains 1 electron. Thus it got the number 1. Helium contains 2 protons and 2 electrons. Thus it got, yes. And then third is lithium. Then comes beryllium. Then comes boron, carbon, nitrogen, oxygen, fluorine and neon. So can you tell me the names of a rainbow? Colors. We use the mnemonics, right? Big G or, so that we can easily say violet, indigo, blue, green, yellow, orange and red, right? Similarly, there are different mnemonics that we use. I personally use this. Hi, hello, listen, BBC News on Friday night. That is the first 10 mnemonics that we use. So what was it? Hi, hydrogen, hello, helium, listen, BBC, beryllium, boron. BBC and carbon. Beryllium, boron and carbon. BBC news on Friday night. You shouldn't go and ask your English teacher whether the grammar is right or wrong. Huh? We just need to study about the names of 1 to 10. So, hi, hello, listen. There can add a 2 into it. 2 BBC News. So, yeah, we're not going to put that into it. So, hi, hello, listen. BBC News on Friday night. That means what? Hydrogen, helium, lithium, beryllium, that is Be, boron, carbon C, and nitrogen, oxygen, fluorine, and neon. Okay, so how is it said? Hi, hello, listen, BBC News on BBC News on Friday night. Nitrogen, helium, lithium, beryllium, carbon, boron, carbon, nitrogen, oxygen, fluorine and neon. Okay. So next line is Na. What is Na? Magnesium. Sodium. It has got the number 11 and then comes magnesium number 12. Why is it 12? Because it has got 12 protons or 12 neutrons in it. Thus it got the atomic number as 12. Then comes aluminium, silicon, phosphorus is P, 15th number, 16 is sulfur, chlorine, argon, potassium and calcium. So how are you going to learn from 11 to 20? Yes, there is another mnemonic that you are using, naughty Maggie and silly Paul. Sat close at Collavery Cafe. Have you heard of the word Collavery? Yeah, everyone might have heard of that Dhanush song. Why this Collavery, right? Okay, here the mnemonics used is we are talking about some naughty Maggie. Okay, naughty Maggie, sodium and magnesium. And silly Paul. Who's that? Whoever. That Paul is very silly. So, and A, aluminium. S is silicon. P is phosphorus. What did they do? They sat close at. They went and sat somewhere. They were sitting very close to each other at where? Which place? Collavery Cafe. We have a cafe nearby. So naughty Maggie and silly Paul sat. Sulfur. What is this? Chlorine. At argon. 18th number argon. K. Potassium. And then comes calcium. Ca. Okay. So I want you all to learn about this. Not at least 1 to 20 is a must, and there are several other common metals that we use in our daily life, like iron, then zinc. All those things also need to be learned. That is there in your textbook. We have a table right down over here, symbols of some elements, important elements. So first we need to learn that 1 to 20 elements, and then other heavier metals and other some important metals are given over here. So let's see what they are. Okay. So aluminium we already learnt Al. That is 2. Okay. Al. Then argon Ar. Then boron, bromine, calcium. Cobalt is something which is a little bit important, CO. Copper, we always come across copper in our experiments, and that is Cu. Gold is Au. Iodine, I. Iron is Fe. Lead is Pb. How did lead get its name Pb? It is from the word plumb up. And then magnesium, Mg. That is a 12th element. Neon, Ne, which is the 10th element. Nitrogen, oxygen, potassium, K. Silicon is Si. Silver again, yeah, another metal which is not in the table from 1 to 20. It is a heavier metal, Ag. And then sodium is there, sulfur is there, uranium, U, and zinc, Zn. So it is very important. You may not be able to learn it at one go. By writing it repeatedly, coming across, looking at it, reading it loud, you'll be able to study this. Okay, so next portion we will be taking in during the next class. Till then, see you. Bye bye.